In this video, we're going to start the combinations worksheet on the KutaSoftware website under the infinite geometry section. I'll leave a link in the description below so you know how to access this free worksheet. And you can find it within the statistics and probabilities subsection. Now, for numbers 1 through 4, we're supposed to list all possible combinations. And for combinations, unlike permutation, order does not matter. So in number 1, we have the letters T, V, and W, and we're taking them 2 at a time. So we're looking at the combinations of T, V, W, taking 2 letters each time. So the first combination, T, V. So the only letter that hasn't been with T yet is W. So then we'll take T, W. So T has been with both V and W. However, V has not yet been with W. So then we'll take V, W. So T with V, T with W, and then V, W. Those are our possible combinations in number 1. In number 2, we have A, B, C, and D taken 2 at a time. So we can take A with B, we can also take A with C, and we can take A with D. Now let's look at the letter B. Well, B has already been with A, so we don't need to repeat that. Let's look at B with C. B has not been with C yet, so we'll have B, C, and B also hasn't been with D yet, so we'll also have B, D. Now we'll look at the letter C. C has been with A, C has been with B, but C has not yet been with D, so then we'll have C, D. Lastly, let's look at D. Well, D has been with A, D has been with B, and D has been with C. So there are no other combinations that we need to write down in number 2. Just AB, AC, AD, BC, BD, and CD. And number 3, we have smile, sun, heart, and triangle taken 3 at a time. So starting with smile, we can have smile, sun, and then heart. We can also have smile, sun, and triangle. We could also have smile, heart, and triangle. So the only 3 that have not been together are sun, heart, and triangle. So then we can have sun, heart, and triangle. If we were to look at sun first, remember order doesn't matter, but if we were to try to put sun first, we've already put sun with heart and triangle, and we've also already put sun with heart and circle. And we'll finish it up, we've also already put sun with smile and triangle. So you can see that because order does not matter for combinations, combinations are a lot fewer than permutations. And lastly, for number 4, we have the numbers 4, 5, 6, and 7 taken 4 at a time. Well, that's going to be all our numbers. 4, 5, 6, and 7. There's no other combination where we can take 4, 5, 6, and 7. There are more permutations, however, for combinations, there's only one combination of those 4 numbers. For numbers 5 through 14, we're going to be evaluating each expression. And I'm going to give you a helpful formula for this. N CR, you can think of this as N choose R, is equal to N factorial over R factorial times N minus R factorial. So think of NCR, in combination R, as N choose R. N is the number of items to choose from, and R is the number that we actually choose. That will give us the number of combinations for the number of items and the amount we choose. So for number 5, 22C 20. 22 choose 20. That's 22 factorial all over 20 factorial times 22 minus 20 factorial. And that's because N is equal to 22 and R is equal to 20. Now, I do not want to write out 22 factorial by hand. That would be 22 times 21 times 20 times 19 and so on. But I can simplify. 22 factorial, I'm going to write as 22 times 21 times 20 factorial. So as opposed to writing out 20 times 19 times 18 all the way down to times 2 times 1, I'm just going to leave it as times 20 factorial. And I left it like that because I have a 20 factorial in my denominator, so I'll be able to cancel those out. So that'll be 20 factorial times 22 minus 20, which is 2 factorial. And like I said, I'm canceling out those 20 factorials, so I'm left with 22 times 21 all over 2 factorial, which is 2. 22 times 21 is 462, and when you divide that by 2, you get 231. So 231 is my solution in number 5. Now I want to also note that there is a button on your calculator that will do the math for you. So if you type in your first number in of 22, then hit math, scroll over to probability, PRB, and go down to NCR, which is number 3. So now on your calculator, after you hit enter, you have 22 NCR, and then enter your R value of 20 and press enter to solve. That will give you 231. There are also combination calculators on the internet that you can search and just type the numbers in. However, for those that do not have that luxury, I'm going to be working these out by hand. In number 6, we have 11C8. So N is 11, R is the number 8. So that's 11 factorial over 8 factorial times 11 minus 8 factorial. I'm going to rewrite 11 factorial as 11 times 10 times 9 times, and then as opposed to 8 times 7 times 6 times 5, I'm just going to write 8 factorial. That's all over 8 factorial times 11 minus 8, which is 3 factorial. My 8 factorials will cancel out, so I'll have 11 times 10 times 9 all over 3 times 2 times 1, or simply 3 times 2. 11 times 10 times 9 is 990, and we're going to be dividing that by 6. And when we do so, we get 165 as our answer in number 6. In number 7, 12 choose 8. That's 12 factorial over 8 factorial times 12 minus 8 factorial. 12 times 11 times 10 times 9 times 8 factorial all over 8 factorial times 12 minus 8, which is 4 factorial. 8 factorial and 8 factorial will cancel out, so 12 times 11 times 10 times 9 is 11,880, and I'm going to be dividing that by 4 factorial, which is 4 times 3 times 2 times 1, which is 24. So 11,880 divided by 24 equals 495. That is my solution in number 7. And number 8, I have 25 choose 23. So it's going to be 25 factorial over 23 factorial times 25 minus 23 factorial. 25 times 24 times 23 factorial all over 23 factorial times 25 minus 23, which is 2 factorial. My 23 factorials will cancel out. So I have 25 times 24 divided by 2 factorial, which is simply 2. 25 times 24 will give me 600, and when I divide that by 2, I'll get 300 for my answer in number 8. In number 9, my N is 24 and my R is 5. So that's going to be 24 factorial all over 5 factorial times 24 minus 5 factorial. Now I'm going to rewrite this as 24 factorial divided by 5 factorial times 24 minus 5 is 19 factorial. So my 19 is my larger factorial in my denominator, so I'm going to use this when canceling out with my 24 factorial. So 24 times 23 times 22 times 21 times 20 times 19 factorial is going to be all over 5 factorial which I'm going to write as 5 times 4 times 3 factorial, and that will be multiplied to 19 factorial. Now you may be asking me why I wrote it as 5 times 4 times 3 factorial as opposed to just 5 factorial. Well, I know my 19 factorial will cancel out the 19 factorial, and 5 times 4 will cancel out with 20, since 5 times 4 is 20. So 24 times 23 times 22 times 21 is 255,024. And I'm going to be dividing that by 3 factorial, which is 3 times 2, or 6. So when I divide that by 6, I'll get 42,504 as my solution in number 9. And number 10, 17, choose 10. 17 factorial all over 10 factorial, 17 minus 10 factorial. So 17 factorial, I'll write as 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 factorial. That's all over 10 factorial times 17 minus 10 factorial is 7 factorial. So my 10 factorial and 10 factorial will cancel out, and 17 times 16 times 15 times 14 times 13 times 12 times 11 is equal to 98,017,920. And I'm going to divide that by 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2, which is 5,040. So when I do out that math, dividing 98,017,920 by 5,040, I'll get 19,448. That is the number of combinations given 17 items and choosing 10. Now I want to remind you that if you don't want to do this all out by hand, also if you hit the math key on your calculator, you can scroll over to probability, and 4 down, number 4, is the factorial symbol. So you can be using that instead. In number 14, we have 4 times 18, choose 11. So that's 18 factorial all over 11 factorial times 18 minus 11 factorial. So 18 factorial all over 11 factorial times 18 minus 11 is 7 factorial. Now I'm going to use my calculator to solve from this step. So I'll type in 18, and I'm going to go to math, scroll over to my factorial button, so 18 factorial, and then I'm going to divide that by 11 factorial times 7 factorial. So making sure my 11 factorial times 7 factorial is in parentheses, that will give me 31,824. Now that's for the combination 18, choose 11. So I'm going to take 4 and multiply that by 31,824 to get 127,296. In number 12, I have 20, choose 16. So that's 20 factorial over 16 factorial times 20 minus 16 factorial, which will be 20 times 19 times 18 times 17 times 16 factorial all over 16 factorial times 20 minus 16, which is 4 factorial. So that's going to be 20 times 19 times 18 times 17 divided by 4 times 3 times 2, and then times 1. 20 times 19 times 18 times 17 is equal to 116,280, and when I divide that by 4 times 3 times 2 times 1, which is 24, I'll get 4,845. However, I'm not done because I'm adding 1 to that. So 4,845 plus 1 equals 4,846. 4,846 is my solution in number 12. In number 13, I have 20, choose 5, but I'm dividing by 8. 20, choose 5 is 20 factorial all over 5 factorial times 20 minus 5 factorial, which is 15 factorial. That's equal to 20 times 19 times 18 times 17 times 16 times 15 factorial all over 5 times 4 times 3 times 2 times 1 times 15 factorial. 20 times 19 times 18 times 17 times 16, 1,860,480. If I divide that by 5 times 4 times 3 times 2 times 1, I'll get 15,504. However, I need to take that value and divide it by 8. And in doing so, my solution will be 1,938. And lastly, for this set of directions, number 14. -6 plus 19, choose 5. 19 factorial over 5 factorial times 14 factorial. That's 19 times 18 times 17 times 16 times 15 times 14 factorial all over 5 times 4 times 3 times 2 times 1 times 14 factorial. 19 times 18 times 17 times 16 times 15, that equals 1,395,360. And when I divide that by 120, which is 5 times 4 times 3 times 2 times 1, equals 11,628. But I'm taking -6 and adding that to 11,628, which adding -6 or taking away 6 will be 11,622. That is my solution in number 14. For number 15 and 16, we have a critical thinking question. It says to explain why n choose 2 is equal to n choose n minus 2. Well, if we look, n choose 2 is n factorial over 2 factorial times n minus 2 factorial. And n choose n minus 2 is n factorial all over n minus 2 factorial times n minus 2 factorial. This left-hand side down, so this will be n factorial all over 2 factorial times n minus 2 factorial for now. Not simplifying that left-hand side down for now, but looking at this right-hand side, n factorial over, we have n minus 2 factorial, and n minus 2. If we were to rewrite n minus 2, n minus n minus 2 is the same as n minus n plus 2, which n minus n plus 2 is 2. And remember, we're taking the factorial of that. So we can rewrite that as 2 factorial. And multiplication is commutative. So n factorial over 2 factorial times n minus 2 factorial is the same as n factorial over n minus 2 factorial times 2 factorial. Those are equal. So this is explaining by going through the formula, although now let's think about it in words. We're choosing 2 for the first one, and in the second one we're choosing all but those 2. So choosing n minus 2 means that 2 are being left behind, and you could think of it as choosing 2. And lastly, number 16, it says to write a combination that equals 12,345. Now this seems like it'll be tricky, but I promise you it's not. So if you want a combination to equal 12,345, think of this as 12,345 times 12,344 factorial. We need that to cancel out in the denominator. Remembering our formula, n factorial over r factorial times n minus r, we want that r value to be 1. If that r value is 1, 1 factorial is simply 1, and n minus r, 12,345 minus 1, is 12,344 factorial. So you can see that that will cancel out. And we'll just have 12,345 over 1, which equals 12,345. So we're going to want 12,345 combination 1. That is our solution in number 16. If you have any questions, leave them in the comments below. And if you liked this video and found it helpful, click that like button, and while you're at it, subscribe to my channel. All likes and subscriptions are greatly appreciated. And if you've already done so, thank you for your support.